Hi everybody, I am Jeffrey Hauser, author of the Learn With series. Thanks for checking these screencasts out. Today we're going to talk about writing tests against asynchronous code within an Angular application using Karma and Jasmine. This episode will show you how to write code using Angular's waitForAsync method. I have here the Learn With application. It's a task manager application which shows you how to build Angular if you read through my books step by step. And I'm going to hone in on a specific section of code here. So I'm going to log into the application, and where a promise comes in, if I create a new task, I'm using ng bootstrap library here, and when it creates this pop-up modal, it returns a promise so we can respond to the close. So creating a brand new task, and the same code is used for both creating a new task and editing a task. And I'm going to show you the code behind this. I have this method here. It's a private method inside this tasks component. What it does is it grabs the modal service, which is ngb modal. So it's a provider or a service that comes from this ng bootstrap library used strictly for opening modals. And we're opening one, and we're doing an instance of the task cu component, which is the pop-up for creating or updating a task. That's what the cu stands for there. We're passing in a title and a task instance, and then we listen to this result then. That's how we listen to promises. If you do a lot with Angular, you probably are aware it does a lot with observables, but doesn't usually use promises, but this library returns a promise. So when we close the modal, we pass the updated or brand new task object, and then we do some bunch of processing with it. Either if it was brand new, we basically add it to the task grid array and then refresh the grid. Otherwise, we replace the object inside the sort of task grid array with the new updated one. So these are the things that happen when we close the module. And if the pop-up is closed without, or canceled rather, we have this catch here, but in the code nothing happens with the catch. So I want to take a look at the test code. I went to split screen so we can see the code we're testing up top and the test code at the bottom. This often works better with a much bigger screen resolution, but we can deal with it for the purposes here. So a lot of this is set up by default by Angular, but we have an instance to the component inside the tasks component, and we have an instance of the fixture. We also added an instance of the ngb modal service. And after the test bed is compiled, I've already added in the relevant components needed. We're going to grab an instance of this test bed in the before each. Beyond that, we are going to, I created a describe block for open test window. And it's going to grab an instance of the ngb modal ref. This is a reference to the item that's popped up, the modal in the UI. We're going to call the modal service, which is a local value, and we're going to pass in the TCU component. Basically, within the test, we're replicating this first line of the open task method, and that gives us an instance of the ref that we can control in tests. So we can control when we close it. And then we're going to actually spy on the modal service open and return this modal ref instance that we control. So when the tests run in here, it's going to call this, and instead of calling that method and creating it, the spy is going to know to intercept it and return this own modal ref instance. From here, we're going to write our individual tests. Let's write the tests using waitForAsync. So waitForAsync is a special Angular function. We used it earlier when we set up the test bed, although I probably didn't highlight it in this screencast series. It's basically Angular creating a specialized testing zone that automatically makes use of async await on JavaScript. In fact, this function used to just be called async, like that. But that was changed, I believe, in Angular 12, strictly because to avoid naming confusion between the JavaScript native functionality and the Angular specific method. So first thing we're going to do in this method is open task window, test title. And we're going to get one of our mock objects to pass into the result handler. And I've just been using task 5. So then we're going to do if I can spell it, we're going to do a fixture detects changes, and then we're going to do a fixture when stable. So detect changes tells Angular to tick their redraw cycle one step forward, and that'll initialize a bunch of components and stuff. Then when stable, we're telling Angular, or telling this testing framework, that we want to wait until things are stable before running this next block of code. And the first thing we're going to do here is we're going to spy on the refresh, and that is called within the result handler. We don't need to call it. We don't need to try to refresh this component. We just want to make sure it is called, so we're going to use a spy. And then we're going to go ahead and close. And that's going to trigger up the result promise, so this result handler can close, because this is how we tell this ng bootstrap service that, hey, we're closing this modal. But we're dealing with async code, so it's not going to automatically trigger. We have to once again tell Angular to go ahead and detect changes. Click that one redraw cycle, which will force that handler to run. And when it's done, then we're going to run some more code, and in here is where we can run all our assertions. We're going to expect component task grid refresh to have been called, and we can introspect the tasks array to be 14. This relates to our book code and our mock services, which are used by default within the tests. And the detect changes basically trigger to call those mock services, which doesn't hit a real backend because they're all mock, and it uses a sort of in-memory data store. Nevertheless, the default task list is 13 items. We've added one more to it. And let's also make sure that the very last item is equal to the task we tried to add to it. let's throw a bunch of going to debug, and we are going to see how this goes. Oh, opened up off screen, but we do see a browser window popped open by IntelliJ, which should load our debugging Karma suite eventually. I'm going to shut that down. I'm going to shut this down. I'm going to try that again. As much as I love IntelliJ, sometimes it does some weird things with debugging. Launch, open the browser. There we go. That's what I was expecting it to do quickly, relatively quickly the first time. Instead it was just hanging. So here we are. So we call the open. Let's shrink this down a bit. Call the open, copy in the task, chain the result handler for when the modal is closed, detect changes when stable, and I'm going to skip the initialization of the task CU component and just jump right to our next breakpoint, which spies on the refresh. And if we look into the task grid, we see our tasks model has 13 items in it. The text changes when stable. This should trigger the result handler to run. There is no task because we're testing the create a new one method, so the task should be null, which it is. So we're going to go into this condition. We're going to add the new task on and call the task grid refresh method, which we have a spy on. I'm going to hit play again into these last three assertions. Length should be 14. Last item should equal, and refresh to have been called. And then I'm going to hit play. And what we are going to see is, although everything worked, all our assertions ran, we're getting this async function did not complete within blah 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 error. This is actually an Angular issue when using waitForAsync, not Angular. I'm sorry, this is an IntelliJ issue. So, but I stepped through, I showed you the code working. I am going to shut down the debug, and I'm going to go ahead and, nope, didn't want to do debug again. I'm going to run it. If I run it, it actually works. This tripped me up a few times. And if I run it at the command line using just ng test, everything should work fine there too. So there's just a minor issue with the waitForAsync approach when debugging within IntelliJ. See, and boom, that worked perfectly. All green. So yes, I haven't figured out what IntelliJ thinks it's doing or why it times out, or why it's stuck waiting when we debug but not when we run. But this is the code. This is the approach to use waitForAsync. Because of these issues, I tried to avoid this as much as possible. I said earlier using done is my preferred approach when trying to test asynchronous code within a unit test. This concludes my session, 4 podcasts actually, on how to test asynchronous code promises within Angular, Karma, Jasmine, how to write those unit tests. I hope you enjoyed everything. If this is the first one you saw, be sure to check out some of the other 3. I spoke about waitForAsync, which is an Angular thing. I spoke about the fake async zone, which is also an Angular thing. I had an episode on done, which is a Karma thing, and an episode on await and async, which is just native JavaScript. Check them all out. Also check out my book series. Thank you for watching. I hope you found this educational.